Okay, this is going to be another response for you to draft science about acceleration once again. I'm going to play from here.
And then he says 9.8 meters per second squared is acceleration, because that's what we said. That somehow the rate of acceleration is somehow something different, okay, than a rate of velocity. When no, it's just a change in velocity. So yes, it's the same exact thing. You have a rate of changing your velocity, and it's the same as the rate of what's your velocity. So you can say you're going to go 60 miles an hour, but I'm going to decelerate at a rate of 4 miles an hour.
Okay.
That's what you could say, and it would make perfectly good sense.
Okay, so that would make perfectly good sense. You're traveling in a car, you're going 60 miles per hour, and you decelerate at a rate of 4 miles an hour. Now, in the same way, if we pick the gravitational acceleration, your initial velocity is 0 meters per second, and you're going to accelerate at a rate of 9.8 meters per second. Now, what does that mean? You say that's acceleration, okay? What are you gaining? You say, so 0 meters per second, and then you accelerate at a rate of 9.8 meters per second. 9.8 meters per second. What does that imply? You're going 9.8 meters for every 1 second. You are gaining 9.8 meters every second. That's the only information you're giving me. And you call that acceleration. That's only a linear increase of your distance. It's not a linear increase of your velocity. Okay, 9.8 meters every second, that's what you're gaining. So it would be more correct to say you're gaining distance at a rate of 9.8 meters per second. Again, meters per second itself, that implies constant velocity. You're only gaining an amount of meters for every second, which means a linear increase of distance, not a change in distance, a linear change in distance, not a linear change of velocity. However, if you mean that if your initial velocity is 0 meters per second, and if your initial velocity is 0 meters per second, and eventually you're going to have a velocity, you're going to increase, you're going to accelerate towards a velocity of 9.8 meters per second, okay, you're going to have to tell me how long it took me to go from 0 to 9.8 meters per second. If it took only 1 second, okay, then that means that I have gained 9.8 meters per second in 1 second. Meters per second per 1 second, okay? That would be the change in my velocity over time. And that's acceleration. My velocity is changing in time. What is your unit of velocity? Meters per second. What is the unit of time? Seconds. My meters per second is changing every second. Okay, now let's go a little bit further when you start drawing on the board or writing on the board.
But it isn't, say 9.8 over 1 second. That's the rate. Okay, that's the proven fact. Okay.
Yes, I don't disagree with that. You start after once you start your initial velocity is 0 meters per second. After 1 second, your velocity is 9.8 meters per second. After 2 seconds, it's 19.6, etc. I don't disagree with that. That's
proven this one.
Sure.
We've dropped things. Galileo did it.
Yes.
We dropped them. We measured it. That's the rate that the stuff falls.
Yes.
Okay, so we know that it gets that velocity. Now we know that as you drop something.
Okay, so you drop something. Your initial velocity is 0 meters per second.
It has to increase its velocity, but that's
Yes.
the final what you're going to get after 1 second. So after 1 second, it'll be traveling 9.8. It will have.
After 1 second, you will be traveling 9.8. 9.8 what? Why don't you say the unit? You start with 0 meters per second. After 1 second, you are traveling 9.8 meters per second. which means after 1 second, I have gained 9.8 meters per second. In 1 second. So 9.8 meters is what I have gained per second in 1 second. And so the next second, I'm going to gain another 9.8 meters per second. And the next second, I'm going to gain another 9.8 meters per second. For every second, I am gaining 9.8 meters per second. In other words, 9.8 meters per second for every second. Meters per second per second. You have to tell me if you have initial velocity. So the change of velocity means I have initial velocity, and then at this point I have another velocity. Okay. 0 meters per second, and then eventually I have 10 meters per second. How long did it took to go from this velocity to this velocity? You have to add time, another time unit, another unit of time. If it's 1 second, then it means 0 meters per second here. It took me 1 second to go from 0 meters per second to 10 meters per second. So I have gained 10 meters per second in 1 second.
Travel the distance, okay, of 4.9.
Because if we are only allowed to use meters per second, then that only applies. Meters per second itself is constant velocity. A change in linear distance, not change in linear velocity. Now, okay, about the distance, the dropping distance, etc. That's, I agree with all that. It's not a problem. All right, so let's now try to explain again how they derive meters per second squared. Now, first of all, per second squared doesn't mean the squared thing is not the exact meaning as when you square numbers. It has a different meaning. Squaring units is not the same as squaring numbers. Again, you don't have to square if it's 5 meters per 1 second squared, you don't, or if it's 5 meters per second squared, it doesn't mean that it's 5 meters per 1 second squared. You don't have to square any number. It's just a notation thing. So if we have meters per second, I'm going to write it differently. Meters per second, it is written as a fraction like that. Meters per second per over a second. Okay. That's how it's written. It's written, you can write it out like this, meters per second. They just figured in physics, well, we can write it even shorter. We don't have to write meters per second, we can write it differently. And so what they do is you can write it as a fraction. Now, of course, you cannot divide meters by seconds. But this is just about units. You do not, the way you do this is not the way you do this with numbers. Okay. It has a different meaning. But they do it in the same way, but it's just for the sake of notation. It has nothing to do with how you numbers, really. It's just for the sake of notation. You want to create the shortest possible way of notating acceleration. No big deal, really. So you write it out as a fraction, meters per second over seconds, and then you want to turn this one also into a fraction. And the way to do that is just to put a 1 over here. Seconds over 1 is the same as just seconds. Seconds divided by 1 is just seconds. So now you have fraction divided by a fraction over fraction. And in algebra, the way to calculate this is to take the reciprocal. So you take meters per second. And then you flip these upside down, and then you multiply it with this. So now we have meters per second times. You take this, but flip it upside down. like that. And then it becomes meters, and then you have to just multiply meters with 1 and multiply seconds with seconds. And that would be meters over second squared. This is just another way of notating meters per second. It's a shortcut. It's just the shortest way possible to notate meters per second, or to notate acceleration. It's just a notation thing. That doesn't mean that when you add numbers in front of these units, so you have now this unit, you have meters per second squared, and now you're going to place a numerical value in front of it, let's say 5 meters per second squared. Well, there's an imaginary 1 over here. For every 1 second, you are gaining 5 meters per second. The mistake being made here is that, or the confusion is that you have to square this number. Well, no, it's separate. The numerical values are separate from the units. It's only about the units. The squared seconds is only about the units. In this case, you should not. So this is separate. You don't have to square the 1, or you don't have to square 5. You don't have to square anything. Second squared just means seconds per second. Second squared has a different meaning than squaring a number, okay? Because second itself, of course, doesn't contain a numerical value. It's a unit. Of course, you cannot square it as you would square numbers. So it means something different. In this case, it just means it's a different way of notating meters per second that you gain every second. Meters per second. It's another way of notating. It's a shorter way of notation, and they did this by using algebra. Is this 100% necessary? I would say no. It's exactly the same as meters per second for every second, and that is necessary. Your change in velocity is your velocity, meters per second, that is being changed in a certain amount of time, and we pick seconds as that unit of time. So your meters per second is changing every second. That is necessary. And the meters per second squared is exactly the same, but just a shorter notation. Of course, this will change nothing about this debate. Nothing will change. So this is a perfect waste of my time and your time. But anyway, thanks for watching, and see you in my next experiment video.